Welcome to C Programming Tutorials. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. In this tutorial we are basically learning about the reasons why you should never return a pointer to local variable. And that's a big mistake, and this is actually a continuation of part 2 of the previous tutorial. If you haven't watched that tutorial yet, please do so. The link to the screen to the part 1 of this tutorial should be on the screen. Anyway, so let's get started. So we saw that if a main function calls of func1, func2, func3, and then func3 return back, and then it calls and all of them return back, and then it calls G1 and then G2 and so on. We saw how it basically overlaps the memory allocation for the local variables of G1 and G2 on top of where the func1 and func2 were actually located. Now the thing is that if you ended up in if any of these functions, right now the return type is not shown here. Suppose if any of those functions, suppose if func2 actually returned a pointer, and if the return value of func2 was integer pointer, okay, and that's perfect. You can return any type from function. So suppose if it was to return an integer pointer, and when it was about to return, it said return, and then it said ampersand f2, which means return the address of f2. Okay, let me write it here. Suppose func2 actually ended like this: return ampersand f2, which means that take the address of f2 and return that back to f1, func1, okay, when it called. And if func1 started using that, that's a big no-no. Why? Because now when the func2 returned, f2 doesn't even exist, kind of. F2 was created somewhere else, here, or actually somewhere here, okay, and it does not even exist here anymore. So it's not a good idea to basically use this memory location, because there is no guarantee. Maybe this will be used for something else like a2, okay, and you cannot be using that value. It will be changing the value for no reason all of a sudden, okay. So this is a big no-no. So that's why you can never ever do that. So we will see this in an example. Now suppose if I write a function here. Let's see. Suppose if I write a function that basically, a program, simple program, which basically takes inputs your name and says your name is, this. So you could do it in just one function, but we are right now we are explaining things here. So let's do something. Let's use some function calls here. So let's see. So what do we have to do? We have to basically, this main function is going to call a function called getName. Okay. Again, I am doing the top-down design here. Okay. So I'm doing top-down design here, so I don't have to worry about the implementation of getName right now. So I'll worry about it later. So getName would be a function which will basically get a name for me, and it will return a name. A name is going to be a string, and a string is actually an array of characters. Okay, an array of characters can be represented by a pointer to the array of characters, right? So it's basically going to return a pointer to character. Okay, so that's what this function is going to return. So I'm going to hold it in a pointer variable, character pointer, p name. It really doesn't matter if you want to do this or you want to do this. Okay, character pointer p name. P name is equal to get name, and then when we get the name from this function, we basically, what do? We do this: print f, your name is %s backslash n for the new line, and then we basically pass the address which is stored in this pointer. Okay, very simple function. It gets a name, stores it into p name pointer, or this pointer, make this pointer point to the name that is returned by this function, and we basically use this to print this message: your name is this. Now all we need to do is to implement this function. So how are we going to implement this function? Okay, let's see. First thing, what is it going to return? It's going to return a character pointer. Okay, name of the function is getName. It's not taking anything as a parameter, and then it has to return a name by asking from the user. So how do you ask from the user? Scanf %s, comma, and then the variable name where you are going to store it. So we have to store it in an array, right? So let's call that array as name. Okay, and let's define, array is basically, we have to store it in the string. A string in C is basically an array of characters. So character name of, I don't know, like, we are assuming that there will be 20 characters maximum for anybody's name. So we are going to declare it as 21 characters. Why? Because we know that one byte or one character is going to be used to show the end of a string. That's how the strings work in C. If you haven't seen the tutorials on strings, please do so. So we do a scanf, but before we do a scanf, let's print some message. It's always a good idea to print a message saying what you are expecting the user to enter. So enter your name. So this message will tell the user to enter a name, and then we store that name in this string name, and then we return the pointer to this name, and what is the address to the start of this name. And what is that address? The name of the variable itself. The name of the string itself is the address of the very first element or very first character or the start of that string. So we are going to return name. Okay, and it is the address. Since it is the address, we can return it as pointer, because pointers take address, right? So this is it. So we have the program ready. So let's see what happens here. Okay, look at this program. Okay, it's all ready, and let's see what is it gonna do. Here we go. We compiled it, F9, we run it, and it is asking for. So first thing it does is it calls this function. This function starts executing. This array is created, and then it says enter your name. It prints it. Then a scanf. It is waiting for us to enter the name, and then we enter this name, and then we press enter. So this name is returned back, and then it is stored. The pointer is stored, and it starts pointing to this variable name here, and then if we print this value out, or at least try to print this value out, your name is pname, and see what we got. Nothing. Okay, it's an empty string. Okay, this pointer is pointing to an address which does not exist. So if you look at this program, just by looking at it, you probably won't know that there is something wrong, but there is a big time wrong here. Okay, what is wrong here? We defined the local variable name here, which is basically inside this function, and then what we did, we returned the pointer to that variable, to that local variable. Okay, and then we used it in the caller. This is not allowed, because as soon as this returns back, this variable is gone, and now this return value, which is now stored in this pname, the address, it's now pointing to somewhere garbage in this in memory on stack. And this function, when we print this thing, it doesn't, it's not going to print anything, or it will print some garbage. Right now it's not printing anything, so it's a big no. So how do you get around it? If you really have to do this, this is what you do. You create the name variable itself in here in the caller where you are going to use it, right? So you create this variable here, 21, and then instead of this, you basically pass it here. So we basically are going to pass this address here, so that this guy can actually put the real name in here. And then now if we execute this program, okay, I have to stop here, and we are running out of time. Thank you so much.